Hello children, today we will be going to do the bases and alkalis part 2. Mostly we will be covering classification of bases, preparation of bases, properties of bases and alkalis and uses. Now classification of bases on the basis of strength or degree of ionization, bases can be classified into two types. One is strong base or alkali, weak base or alkali. Now you know the differences between bases and alkalis. Now bases or alkalis which almost completely ionize in aqueous solutions, these are called strong bases, and these are also strong electrolytes. We will be doing the electrolytes in detail in electrolysis chapter. Now what are the examples? Sodium hydroxide, barium hydroxide, potassium hydroxide. Now if you go for weak bases or alkalis, the bases or alkalis which partially or incompletely ionize in the aqueous solutions are called weak bases or alkalis. These are also weak electrolytes. Example, calcium hydroxide, ammonium hydroxide. Now on the basis of acidity, you can divide the bases into monoacidic base, diacidic base and triacidic base. So we'll first go to what is basicity. What is acidity? Acidity of a base is the number of hydroxyl ions produced by one molecule of a base ionized in water. Now for water insoluble bases, acidity is the number of replaceable hydroxyl ions in one molecule of a base. Now what is monoacidic base? The base which furnishes only one hydroxyl ion per molecule in aqueous solution is called monoacidic base. Now you see the examples: potassium hydroxide, sodium hydroxide, ammonium hydroxide. You see here it has only one hydroxyl group, it has one hydroxyl group, this also has one hydroxyl group. Now when they ionizes in the aqueous solution, you get only one hydroxyl groups. Now this is the equilibrium sign or reversible sign. Now what is diacidic base? Base which furnishes two hydroxyl ions per molecule in aqueous solution is called the diacidic base. Examples are calcium hydroxide, copper hydroxide, magnesium hydroxide. I have shown you the ionization of magnesium hydroxide and calcium hydroxide. So you can do the same for copper hydroxide yourself. You see here these metals are bivalent. In the previous case, the metals were monovalent and this ammonium ion is also monovalent. So here you get two hydroxyl groups. So the basic difference is in the number of hydroxyl groups in the aqueous solution. Now what is triacidic base? Base which furnishes 3 hydroxyl ions per molecule in aqueous solution is called triacidic base. So from the formula itself you can identify. Here the metals are trivalent. So 3 hydroxyl groups and 3 hydroxyl groups. So examples are aluminium hydroxide, ferric hydroxide. Now come to the preparation of bases from metals. When metals react with oxygen, they give the base. Here sodium reacts with oxygen to give sodium oxide. Magnesium reacts with oxygen to give magnesium oxide. Second process, by the action of water on reactive metals. Who are reactive metals? Generally sodium, potassium and calcium. I have not shown the reaction between potassium and water, that you can write the same way like sodium. You can see the reaction over here and the hydrogen gas is produced. This you have already learned in the hydrogen chapter in class 8th and 9th. So sodium plus water gives you sodium hydroxide and hydrogen. Calcium plus water gives you calcium hydroxide and hydrogen. Same for potassium and water will be giving potassium hydroxide and hydrogen. Then by the reaction of water on metallic oxides. The metallic oxides when react with water gives you alkali or base. So sodium hydroxide and calcium hydroxide. Both are called base as well as alkali because these are soluble in water. Now the bases which are soluble in water are called alkalis. This you already know. Next is by double decomposition. So you have salt solution plus base or alkali to give the precipitation of basic hydroxide and the normal salt. Normal salt, you know, the salt which does not contain any hydrogen after reacting with acid and base. This you had already gone through in the acid chapter. So salt solution copper sulfate plus sodium hydroxide give you copper hydroxide and sodium sulfate. Ferric chloride plus sodium hydroxide will give you ferric hydroxide plus sodium chloride. Aluminium chloride plus ammonium hydroxide will give you aluminium hydroxide and ammonium chloride. These reactions will again be seen in the chapter 4 in the analytical chemistry portion. So learn these equations properly. Next, the preparation of bases is by the action of oxygen on metal sulfides. When these metal sulfides are burnt in oxygen, they will give you the metallic oxides which are the bases and sulfur dioxide. Now by decomposition of salts, when metallic carbonates are heated, I have shown this heat symbol of heat only in the basic reaction. You should write this heat symbol on every arrow when you will write the reaction. Similar for this carbon dioxide arrow and sulfur dioxide arrow. These arrows are for the gases. So calcium carbonate when decomposed gives basic oxide, calcium oxide and carbon dioxide. Same for copper carbonate. These reactions also had been done by you in previous classes. By decomposition of salts. What salts? Metallic nitrates. If you heat metallic nitrates like calcium nitrate and zinc nitrate, you will be getting the basic oxide, calcium oxide and zinc oxide, brown colored nitrogen dioxide and oxygen. Now, sodium nitrate and potassium nitrate, they do not give metal oxide when decomposed. What do they give? Sodium nitrate gives sodium nitrite and oxygen. Potassium nitrate gives potassium nitrite and oxygen. These reactions also has been done by you in class 9. Now how ammonium hydroxide is prepared? Ammonium hydroxide is a weak alkali and weak electrolyte also. These can be prepared by dissolving ammonia gas in water. Now ammonia gas is very highly soluble in water. So ammonia in water gives you ammonium hydroxide, which is a weak alkali. Now what are the properties of bases? They have sharp and bitter taste. They change the color of indicators. Here the list of indicators and their color, respective color in acid and bases are given. You should learn all this. Red cabbage water may not be required for ICSE syllabus, but other 4 are very much required as per ICSE syllabus. Soapy substance. These are strong electrolytes except the weak bases or alkalis, and they have the corrosive action on the skin. Now, here you should know that caustic soda, that is sodium hydroxide, and caustic potash are strong alkali. Caustic potash is potassium hydroxide. Now you have seen in the previous class, that is in class 9 water chapter, that the alkalis react with oil to form soap. Now our skin contains oil in the form of fat. So when we touch caustic soda or caustic potash, a reaction takes place and a soapy solutions are formed. So when we touch caustic soda pellet or caustic potash pellet, we feel soapy and it is slippery. Now the chemical properties. Strong bases or strong alkali absorb carbon dioxide. to give the metallic carbonate and water. Now, acid and base, when they react with each other, they will give salt and water only. So, potassium hydroxide with HCl gives you potassium chloride and water only. Similar for these other two reactions. Here I have shown these two are both acids and alkalis and bases. This is the base. Heavy metal like copper, zinc, iron salts on reacting with alkali or base precipitates insoluble metallic hydroxide. These three reactions again are important for your chapter 4, that is analytical chemistry, as well as your practical chemistry, that is chapter 13. Sodium hydroxide when react with zinc sulfate gives you sodium sulfate and gelatinous white zinc hydroxide precipitate. This is the insoluble hydroxide. So this is the precipitate sign. Sodium hydroxide with iron sulfate gives you this dirty green ferrous hydroxide and sodium sulfate. Ammonium hydroxide with copper sulfate gives you ammonium sulfate and blue color copper hydroxide. Now, lead hydroxide, zinc hydroxide, aluminium hydroxide. These are amphoteric in nature. What is amphoteric? The hydroxides or oxides which react both with acids and bases. Now these being amphoteric in nature dissolve in excess sodium hydroxide or potassium hydroxide to produce salt and water. But other hydroxides which are not amphoteric, they do not do this. Now zinc hydroxide when reacts with sodium hydroxide gives you sodium zincate and water. Now as alkalis are warmed, the heat sign is given over here on the basic equation. You have to give in all the equations whichever you will be writing. So when alkalis are warmed with ammonium salts, ammonia is produced. Alkali, ammonium salt gives you salt, that is sodium chloride here, water and ammonia. Potassium hydroxide, ammonium sulfate gives you potassium sulfate, water and ammonia. Similar for the reaction between ammonium chloride and calcium hydroxide. For such reaction, you will be getting the smell of ammonia. Here, I have not put the up arrow. You should put the up arrow, or you should write G in bracket beside ammonia, because ammonia is the gas. What are the uses? These are given over here. Sodium hydroxide is used in soap manufacturing. Calcium hydroxide or slaked lime used in manufacturing of bleaching powder, softening of hard water, neutralizing acid in soil and in water supplies. Potassium hydroxide are used in salts and soap manufacturing and in batteries. Magnesium hydroxide is used in antacid. Aluminium hydroxide is used in foaming agent in fire extinguisher. Ammonium hydroxide is used for removing stains of grease from clothes. Magnesia is used for making refractory bricks. Calcium oxide is used for drying agent. Thank you for patience hearing. Subscribe my channel for more videos on chemistry and polymers. Thank you.